Welcome to True Projects. In this video, we are going to discuss about the project, which is a comprehensive analysis of autism detection in pediatric healthcare. So before getting into the execution, first let's understand what is the project about. As many of you may know, autism spectrum disorder, that is ASD, it is a complex neurodevelopmental disorder and it can significantly impact child's daily life. It affects child's social relationships and behavioral patterns, creating various challenges for those who are affected with this ASD, that is autism spectrum disorder. So traditionally, ASD is diagnosed using behavioral observations. So these observations they are usually made around the age of 2, which unfortunately means that there is often a delay in diagnosis, which in turn leads to delay in the initiation of crucial treatments. So to overcome these limitations, our project focuses on developing an advanced ASD system utilizing machine learning and deep learning models. So, our goal is to create a more efficient and timely diagnosis process, allowing for earlier intervention and better outcomes for children affected by ASD. So, moving on to the proposed work of a project. So, in the proposed work, we have employed quantile transformer for scaling the features, and also we have employed 8 different machine learning models for checking the probability of detecting autism spectrum disorder. And then we also have employed convolutional neural network as well as deep neural network for image based analysis, that is for checking the autism spectrum disorder using images of the children. So moving on, our project involves a detailed workflow starting with the data exploration. So first we do the data exploration and then we pre-process the data, which includes cleaning the data, normalizing it, and selecting the important features to ensure accuracy. And then we train machine learning algorithms that are random forest, logistic regression, and AdaBoost, etc. So also we assess them using cross-validation to avoid overfitting. And we emphasize models interpretability for transparent predictions and incorporate image-based analysis using CNN and DNN. And the performance of all the models is evaluated using accuracy, precision, recall, and FN score. So after evaluating the best performing model, that is one from machine learning model and one from deep learning model are selected for deployment. So these models are integrated into the front end application built using Flask, which is integrated with SQLite for user testing and user authentication. So this is how we will be implementing the project. Moving on, our project primarily benefits at risk of autism spectrum disorder, that is, children at risk of ASD and their families, healthcare professionals, researchers in developmental disorders. So, by utilizing machine learning techniques and innovative image analysis methods, we aim to facilitate early detection of ASD in pediatric populations. So, this early detection allows for timely intervention and support, significantly improving long term outcomes and the quality of life for children with ASD and their families. Moving on to the algorithms used. So, first we have machine learning models that are used for detecting the autism spectrum disorder from the structured data, that is CSV data. And the last two models are the deep learning models. We have utilized deep learning models for detecting autism spectrum disorder from the images of the children. So from machine learning models, we'll be selecting one best performing model, and from deep learning, we'll be selecting one best performing model. So from machine learning, as SVM is performing well, so we have selected that for deployment. And coming to deep learning, CNN is performing well for detecting the ASD from the images. So we have selected CNN for deployment. Moving on to the requirements. To implement this project, we need software and hardware requirements. So coming to these software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. And moving on to the hardware requirements, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Now let's execute the project. To execute it, we need to open the code folder which contains source code file. So this is the code folder of a project. So now we will understand all these files individually. How will they be used in the project? So first, let's explore the dataset folder in which we have datasets. Open the dataset folder. Here we have three subfolders. One is autism screening child data and the other one is autistic, and last one is non-autistic. So in last two folders, we have image related data, and in the first folder, we have CSV data. So open the autism screening child data. Here we have two subfiles. One is autism child data and the other one is description for this autism child data. So open the autism child data file. So these are the parameters that are attributes using which we'll be detecting ASD disease, that is autism spectrum disorder. And here we have data for all those attributes. Here's the data of each individual child. And here we have two target classes. One is no and other one is yes. No means the child is not having ASD disease, and yes means child is suffering with this ASD disease. So we'll be using all this data to train the machine learning models to detect ASD. Now close this, get back. Here in the autistic folder, we have images of those children who are suffering with the ASD disease. So here we have 1470 images of those children who are suffering with the ASD disease. Now get back. Similarly, in non-autistic folder, we have images of those children who are not suffering with the ASD disease. And these are also of 1470 images. Get back. We'll be using autistic folder and non-autistic folder to detect the ASD using images. And we'll be training deep learning models using this two folder datasets. Now get back. So moving on to the model file, here we have algorithm information that will be loaded into the project code during runtime. And here in the sample folder, we have test cases using which we'll be detecting autism spectrum disorder in the front end. Get back. And this is the static folder. This folder contains files related to project styling and interactivity, including CSS, JavaScript, and Bootstrap files. So these resources are crucial for enhancing visual appeal and functionality for the project's web interface. And this is the templates folder. Here lies all the HTML pages utilized in the project. They are index.html, about.html, etc. And each HTML file represents a different page of the website and provides structure and layout for displaying content to the users. And this is app.py file. This Python file encompasses the front-end logic of the project. It handles server-side operations, including processing user requests, interacting with the database, and dynamically generating content to be presented in HTML templates. And here we have two IPYNB files. So these are the Jupyter Notebook files which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. So here in the child sample folder, we have test cases. So we'll be using all of these test cases to detect autism spectrum disorder in the front end. Now close this. And here, last file we have is signup.db file. This file is a database file which is used to store the user information. So now we will execute the project. To execute it, we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we need to open the Anaconda prompt. Using the command cd followed by the space, paste the copied path and then click on enter. So here we can observe that current directory is changed to the code folder's path. Now compile app.py file by giving the command python space app.py and click on enter. So this command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port, unless configured differently. Now copy this local link provided by the Flask framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Paste the link here, click on enter. So this is the web page of the project, which is displayed in the browser, and this web page is built using Flask framework. So to execute the project, we need to sign in. So click on sign up here and enter all the registration details if we are signing up newly. I have already signed up and have an account in it, so I'll directly sign in. So click on sign in and give the username and the password. Now click on sign in. I've signed in successfully and I'm redirected to prediction page. So here we can see a choose file button. We need to click on that for uploading the images. So click on choose file. So click on choose file. Here we have children images. So we need to select any of the children image and upload it. So I'm selecting the first image. Click on open. Here we can observe that image is loaded. Now click on upload. Image has been uploaded and now it's time to enter the parameters. So we need to enter all these behavioral attributes and then click on predict to detect whether autism spectrum disorder is detected in the child or not. So first attribute, which is A1, it is yes. Moving on to A2, it is no. A3 is also no. A4 is no. A5 is no. A6 is no. A7 is no. A8 is no. A9 is no. A10 is no. And the gender is male. Ethnicity is white European. So select white European. Moving on to jaundice, he has no jaundice and he has no autism. And country of residence is Europe. Moving on to used app before, he has not used app before. So select no. Age description is 4 to 11 years and relation is relative. Now click on predict. So here we got the prediction based on the given input image as well as the parameters which we have entered. So here we got the prediction as the child has no ASD based on the input provided. Let us enter some more test cases. So click on try again. Now click on choose file. So we need to select any image. So I'll be selecting this image. Sorry, I'll select this image. Click on open and now click on upload. So image is uploaded. Now it's time to enter the parameters. So A1 is yes. A2 is also yes. A3 is yes. A4 is yes. A5 is yes. A6 is yes. A7 is yes. A8 is also yes. A9 is yes. A10 is yes. And the gender is male. And ethnicity is others. So select others. And he has jaundice. And he has no autism. And the residence is United States. So click on choose. And here select United States. And he has not used the app before. Age description is 4 to 11 years. And the relation is parent. Now click on predict. So based on the provided input image and the parameters which we have entered, here we got the prediction as no ASD based on the input provided, which means that child is not suffering with the autism spectrum disorder. Let us enter some more test cases. So click on try again. Click on choose file. So now we will select click on choose file. So I'm selecting this image. Click on open. Image is loaded. Now click on upload. Image is uploaded. Now let's enter the parameters. So the A1 is yes. A1 attribute is yes. A2 is yes. A3 is no. And A4 is yes. A5 is no. A6 is also no. A7 is no. A8 is also no. A9 is no. And A10 is no. And gender is male. Ethnicity is Asian. Jaundice, he has no jaundice. And he has no autism. And he's an Indian. So select Indian. And he has not used the app before. Age description is 4 to 11 years and relative is parent. So now click on predict. And here we got the prediction as child is suffering with the ASD based on the input provided, which means that the child has autism spectrum disorder. Now let us enter one more test case. Click on try again. Click on choose file. So I'm selecting the fourth image. Click on open. Here we can observe that image is loaded. Now click on upload. And now let's enter the parameters. So the A1 value is yes. A2 is no. A3 is yes. A4 is yes. A5 is also yes. A6 is yes. A7 is no. A8 is yes. A9 is no. And A10 is yes. And gender is female. Ethnicity is Middle Eastern. Jaundice, she has jaundice. She has autism. And the country of residence is Bulgaria. And she has used app before. Age description is 4 to 11 years and relation is healthcare professional. Now click on predict. So here we got the prediction as child has autism spectrum disorder based on the provided input. So now click on sign out. In this way, just by entering the parameters to the system and uploading images to the system, it will detect autism spectrum disorder whether it is present in the child or not.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.